So let's look at this simple previous problem from the topics limits, continuity and differentiability. So it is a simple problem for sure, but often simple problems actually teach you a lot of concepts. So this is one such problem. It says let f of x is 4. So f of x is set to be a value 4 and f dash x is set to be 4. Then what is this given by, right? So what happens, like what happens when you put when I say x is tending to 2, right? X is tending to 2, that means x is somewhere very, very close to 2. So what we first do is usually we put 2 in the expression and see what we are getting. So let's first put 2 in this expression. What you get is 2 into f of 2 minus 2 into f of 2 here, right, divided by 2 minus 2. So as you can see, what you are getting is 0 by 0. I have to tell you a lot about this 0 by 0 actually. It's one of the indeterminate forms. What do you mean by an indeterminate form? Is it actually a 0 here and is it actually a 0 here? The answer is no. It's not actually a 0. In fact, if it's actually a 0, if both of them are actually zeros, you can't do anything about the problem at all. You can't. What is happening here is x is tending to 2. X is not 2 actually. If x is actually 2, if I say that this expression, capital, let it be capital F of x divided by x minus 2. If I ask you what is f of 2, you will say not possible to determine. You won't even say it's infinity, right? It's not, because it's completely a 0 by 0, right? It's exactly 0 by 0. It is actually 0 by 0. You can't say anything. But here it's not the case. Is it actually 0 here? No. Why? Because your x is tending to 2. It's very, very close to 2, but it's actually not 2, right? So if it's very, very close to 2, that means it's a very, very small value. It's a very, that means this numerator is a value very close to 0. Denominator is a value very close to 0. So their ratio can be some finite value, right? How? Because if you have something like a 0.0001 and something like a 0.00002, then ultimately what you have is a 10 by 2, right? You have a 10 by 2, you have a 5. The ratio is finite, even though they are very small, but the ratio is finite. But you will say that, okay, this is approximately 0, it's approximately 0, and this is something like that, right? If it's exactly 0, then I can't determine anything. But in the problem, what's happening is x is tending to 2, so they are close to zeros. And then you can apply what is known as L'Hopital's rule. Don't mind the spelling, I don't remember that, but that's what it is. What it says is, if your function, some f of x by g of x, such that your limits x tends to a, takes the 0 by 0 form. What does this mean? This f of x is not I'm not putting a here, I'm not putting a here, right? I'm not writing that f of a, I'm not asking you what is f of a by g of a, because that is completely 0 by 0 and I can't do anything about it. I'm asking you, what is, if your x tends to a, then what is this ratio, right? It's not exactly a. That means it's some value which is very close to 0, some value very close to 0, and the ratio will be finite. When it takes this form, what I can simply write it as, I can use this, I can write this. I can differentiate this function separately, differentiate this separately, take their ratio and put a in there, calculate the limit for this ratio. This limit will be equal to this limit, right? So I can say f of x by g of x, limit x tends to a is equals to limit x tends to a f dash x by g dash x. And when can I say this? When this takes the 0 by 0 form, when it's not exactly by 0 but takes the 0 by 0 indeterminate form. I hope you have understood the difference between indeterminate form and the actual 0 by 0, right? So here it's taking a form because x is tending to 0. So what I'll do is I'll simply differentiate this, differentiate the upper part separately. So it's 1 into f of 2 plus x into f dash of 2, which is a 0. Why? Because f dash of 2 is a constant actually, because if you put 2 in this function, it becomes constant, right? And you're taking a differential of the constant, so it will be 0. So this is minus 2 into f dash of x, and your x is tending to 2, and the denominator is differential of this is simply 1. So I'm doing the ratio of the differential. I'm not doing u by v rule, mind you, I'm not doing u by v, I'm doing differential of this by differential of this. So you simply have f of 2 minus 2 into f dash of x, and your limit x is tending to 2. F of 2, what is f of 2? F of x is constant, right? F of x is 4, f of 2 will also be 4. This is 4 minus 2 into, what is f dash of x? F dash of x is 4, right? So f dash of 2 will also be 4. So this is 4. So you have a minus 8 plus 4, you have a minus 4. So the answer to this question is minus 4.